Hello and welcome back to Advent of Code 2023. Oops, I'm on the wrong screen. Just do that. Day 22. All right, so as you can see, I have not finished day 21 because I had a flight and that kind of put me out of work for one day. So rather than try to, I don't want to be behind with these problems, so I'd rather tackle today's problem and try to always tackle the problem of the day. And then when I find time, I can try to finish off 21. That way, better to leave gaps than to actually be behind. That way I can still kind of be in the know of today's problem and understand what everyone's saying in the community and stuff about today's problem. All right, so we're going to do 22 today, and 21 will return in the future. Yeah, so 22. Okay, sand slabs. What kind of problem is this? Turn the sound down a bit as well. Right, don't know. From the brief look, I have no idea what kind of problem this is. Alright. Oh, it looks like Tetris? Okay, we'll see. Enough sand has fallen. Ah, falling sand. Is this going to be another thing you can solve with Minecraft? It can finally filter water for Snow Island. Well, almost. The sand has been falling as large compacted bricks of sand. Got some cashew nuts. I can eat some of them. Bricks of sand piling up to form an impressive stack here near the edge of Island Island. In order to make use of the sand to filter water, some of the bricks will need to be broken apart, nay, disintegrated back into freely flowing sand. This is so Minecraft. The stack is tall enough that you'll have to be careful about choosing which bricks to disintegrate. If you disintegrate the wrong brick, large portions of the stack could topple, which sounds pretty dangerous. The elves responsible for water filtering operations took a snapshot of the bricks while they were still falling. Your puzzle input, which should let you work out which bricks are safe to disintegrate. For example, what the heck is this? Alright. Each line of text in the snapshot represents the position of a single brick at the time the snapshot was taken. So we've got two XYZ coordinates, one for each end of the brick. Each brick is made up of a single straight line of cubes. And the elves were even careful to choose a time for the snapshot that had all of the free-falling bricks at integer positions above the ground. So the whole snapshot is aligned to a three-dimensional cube grid. So this one's a single cube. That makes sense. So here we've got 0010 to 1010. So which way does gravity go? It's in the Y? The Z? Z, apparently. This one's vertically. Alright, so... No. Yeah. Yeah, Z, okay. Alright, so Y is horizontal, Z is vertical. Because, like, in Minecraft, it's Y is vertical, Z is horizontal, so... But we're not doing Minecraft, so I should stop bringing up Minecraft. kind of want to play Minecraft now, but anyway. 2 cubes in volume horizontally, sure. 10 cube brick. Alright. Ground is at Z equals 0 and perfectly flat. Like in Minecraft. Creative mode. The lowest Z value a brick can have is therefore 1. Okay, fine. Alright. Why are we going with 1 as the... Okay, it doesn't matter. Some bricks will still be in the air. You need to start by figuring out where they will end up. Bricks are magically stabilized, so they never rotate. Even in weird situations, like where a long horizontal brick is only supported on one end. Okay. See where this is going. At the time of the snapshot from the side. Okay. So this is X, Z. Alright. Yeah, okay. So, question mark means bricks are hidden behind other bricks at that location. Fine. Yeah. So we just simulate their falls, right? Now that all of the bricks have settled, it becomes easier to tell which bricks are supporting which other bricks. First task is to figure out which bricks are safe to disintegrate. Hello, DOJ. Okay, so it's basically Tetris. So we can disintegrate bricks, which no other brick would fall directly downward. Interesting. Saw you streaming earlier doing yesterday's puzzle. Yeah, I started on problem 21. I haven't finished it though. But I want to keep up with the latest problems, so I'll come back to that. But hopefully I can finish 22 today. And then maybe, I don't really want to do any more today. Maybe tomorrow I can try and do a bit more 21. 21 is kind of difficult. It involves a lot of, I would say, algebra. Yeah, I'm actually going to have to sit down and do some algebra. Basic maths. Yeah. It is basic algebra in the sense it's not going to like second order, third order, like quadratics or anything. It's just linear stuff. But yeah, it's pretty confusing and it needs lots of Microsoft Paint diagrams to work it out. Well, I shouldn't be thinking about it now. That would just distract me. So you can have weird situations here where... Okay, so if you have a block which is resting on 2 blocks, and if you remove one of them, the block won't fall. So that left one let's say there's a left block and there's a right block, and there's a block resting on both of them. So you can remove the left one, so that's disintegratable, and you can remove the right one, so that's disintegratable. So they're not, so obviously they're not simultaneously disintegratable, but I think what they're getting at is here is they just want to find out which ones are individually disintegratable. With what would happen if for each brick, only that brick were disintegrated. Okay. Bricks can be disintegrated even if they're completely surrounded by other bricks. Fine. So disintegrated just means disappear. Okay. So, what is the basic definition of... What is the basic condition for something to be disintegratable? I think we need a dependency graph here, don't we? So they only fall if they have no support, yeah. So basically, we need a graph. For every block, we need to point to the blocks we are resting on. And it's going to be a bidirectional graph, because not only do we want to know which blocks we're supporting, we also want to know which blocks we are being supported by, because both of those operations will be done at some point. Whoa, wait, will they? Maybe not. Yeah. It's so we need a bidirectional graph, so it's just like an undirected graph. Okay. So the moment let me have a think about this. Let me get my tea. Okay, so if a block is resting on two or more things, then you can immediately say all of the things I'm resting on are not disintegratable. It completely rules them out from being disintegratable. So that is basically an if and only if condition, isn't it? So if I were to build a graph for every block, I have an edge pointing to every other block that I'm resting on. Then I just iterate through all my blocks, and every time I see that I have more than one neighbor, then I go through each of those neighbors and say, okay, you are not disintegratable, you're not disintegratable, you're not disintegratable. So every brick starts disintegratable initially. And then I just do that process. Is this video actually frozen? Hello, the zombie killer whale. Apparently it's not for... Well, we can do the ultimate test, can't we? And just, go infinite hex tree. Seems okay. Okay, enough. I wonder if Twitch messed with not working on Opera again. Oh. Wait, so you tried refreshing and everything? Is it still frozen? Right, so how many bricks could be safely chosen? Okay, so I think this process works. We just draw a graph of every... It's frozen like 3 times, really. Okay, so when a brick falls, when we find its resting point, at that time we can find all of its supporting bricks. And we know there will never in the future be any more supporting bricks. They can't get under the brick. So the time that a brick falls, that is the time at which we can completely determine all of its supports, right? So this is all based on picking the correct order. We have a bunch of bricks in space. I would say we want to process the bricks from lowest to highest, but yeah. So lowest meaning their lowest point. So process them from whatever their lowest point is. If we go in that order, you can never get any weirdness, can you? Because they can never collide with something that's still floating. Oh no, wait. No, they can't. Because if they did, then that thing they collide with should have been processed earlier. Should have been the one we processed. Okay, so yeah. Okay, so the whole algorithm is we've got all our blocks. We start with the ones which have the lowest Z value on the lowest point of their block. So for each block you record where the lowest point is and the lowest Z value, whatever. And going in order from bottom to top, we then simulate what would happen if it drops. Okay, so then we have to just kind of drop it and work out where it ends up. And then when we do, and we land on something, for each of the things we land on, of which there may be more than one, if there's only one thing we land on, we don't do anything. Wait. No. If there's only one thing we land on, then we say that cannot be disintegrated anymore because I'm resting on it. So everything is disintegratable by default. But if we only land on one thing, then the thing we land on, we now know that's not disintegratable, so we change that to false. It starts off as true, we change it to false. And if we land on 2 or more things, then we don't do anything, because those things are still disintegratable, so it's fine. And then we drop the next one, and the next one, and so on. Is that it? Is that what we do? Have a look at the input. Alright, so how can we be efficient? Because I'm guessing... Well, I don't know what part 2 is going to be like, but I think we can just... These blocks aren't complicated, so it's like... For each block we can just scan the full length of it, can't we? Yeah. But we are going to need a couple of maps here. We need, if we land on a block, we need to be able to find out what block that piece belongs to. So we need a map of all individual coordinates and the block that they belong to. We can do that easily. So, and these numbers aren't too big, so if something's floating in space, we can just move it down one by one until we see it lands on something. Even though there's probably a more efficient way of doing that, but fine. Is that it then? We can do the more efficient way. We can say for every XY column, we can keep track of where the highest stable block is, settled block is. And who owns that block. That way, we don't have to drop the block one by one. We can just scan all the columns that it belongs to, check what the highest block is amongst all those columns, and take the maximum, and that's where we end up. And then, we'll know, won't we? Okay. I think I've mentioned way too many things and optimizations. I think we've got to actually get some code down, otherwise I'm going to forget everything. So I can't think, what would they do for part 2? Because the reason I'm trying to be efficient is I don't like the idea of moving them one step at a time, you know, Tetris style. I'd rather do the thing you do when you drop them. I'd rather just drop immediately and know exactly where we're going to end up. But these numbers aren't huge, so it's not that important to do that, but okay. Anyway. It's elegant. So... Oh yeah, this was day 21 stuff. Where's what, 22? Whoops. Paste it here. Alright. So what do we do? We want to record blocks. And I guess we can reuse our pause that we've been reusing pretty much every day for the last 5 days or something. This time it's going to be 3D. So we don't have row and column anymore. We've got X, Y, Z, Okay, so we've got addition. Will we even need addition? Maybe, I don't know. Alright, so let's see. We want a bunch of blocks. A block is defined by a pair, which is its endpoints. So that's on the input. We can get that. I hope I'll be able to finish this today because I don't like leave. I don't want to leave 2 problems hanging. That's. You know, I want to finish by Christmas Day. On Christmas Day, and get that 50-star message. Okay. Yeah, so let's just... Well, we don't need to enumerate here. Just have 5 puzzles to finish on Christmas. Try to avoid that. Christmas Day, usually the problem is not too hard, and it's only a part 1. So... Because he knows that people will actually spend all day on the problems and neglect their families if he gives us a hard problem on Christmas Day, so... Alright, so we want left, right equals line dot script dot split tilde. That's a new character we're splitting on. So can I just end 1 equals left dot split comma can I just send this into pos as arguments? Does that work? Let's check if that works. Left dot split. Oh no, that's a list. I meant to do star. That takes us the iterable and passes it as arguments. That should work, right? Yeah, except we want these to be ints. So, can we? Okay, can we just do this? Map int left dot split. Right, let's compare. Do we still have to do star? Ah, interesting. Okay. Like this. Perfect. All right. I mean, you could actually compactify this whole thing into one line. No point in doing that. Alright, so let's make it readable. Blocks dot append. So a block. Alright, I think better to make blocks a class. I want to be able to point to an instance of a block and it changes its location, but still that instance points to the same block. I can't do that with a tuple. Let's make a block class. Get data class. I feel like a lot of the time might as well just make it a data class. Endpoints is going to be tuple of pauses? Does it like me doing that? Object tuple, no, that should be square brackets. Okay. Blocks.append, so we need block and 1 and 2. That. Why doesn't it like this? Tuple. Got tuple pause. What? It's a tuple of pauses. Tuple pause. Is that, what was it? Okay, just do that. Interesting. I don't know what this notation really means, but I'm guessing. Okay, fine. So is this interesting? Okay. So that's how we define a block. Alright, what do we do with that? These blocks are currently floating in space. We get lowest point. Return. So we want the minimum of the z values. So it's gonna be end 3. No. N.z or end in endpoints. Self.endpoints. That's the lowest point on that block. So that's one thing we need to check. Because we want to order the blocks by the lowest point. Um, we want to get cubes? Yes, we do. Alright, this one's an interesting one. So, only one of these directions has it vary, but we can do a triple for loop. It's just that some of these for loops will be vacuously, well, they'll just have one item in them, so it'll work. It won't be we won't have lots of. Okay, so we do 4x in range, so basically it's going to range from self.endpoints. Hang on. Well, the one could be negative. Hang on. If you've got a number and another number, how do you get all the numbers between them? If you could just use range, but then it could be negative, in which case you have to do it differently. Or could I just... You'd have thought that'd be a really clean method for doing this, isn't it? Just, I mean, we could, I don't know. Start from the minimum of the two endpoints. This doesn't look clean, but whatever. Self.endpoints. I don't like calling it endpoints. Can we just rename to ends? I don't want to have to keep typing endpoints. Okay. So it's minimum of self.ends 0 dot x self.ends 1 dot x. Okay. Or I'll just write it like this: p.x for p in self.ends. I don't know, that just looks better. Max +1, because we want to include that point. So for x in that range, this is. We'll just do it this way. I don't know of a cleaner way of doing this. So now we have to do it for y. Y in range. For z. Yield pos x, y, z. So we create a new pos which just represents one cube on that block. So if we do this, we'll get all cubes. Yeah, this looks horrible, but whatever. So is that everything? Alright. The other thing I want is... Okay, we got the blocks. Let's run it to make sure everything's fine. Okay. Is integratable? Is that how you spell it? Disintegrate, yeah, probably. Was there an E there? No, I don't know. Is that even a word in the dictionary? Disintegratable. Let me Google this. Disintegrable. Capable of being disintegrated. Oh, you don't put the great, you just say disintegrable. Disintegrable. And that means can be disintegrated. Disintegrable. Okay. Fine. Alright, so when we create the block, we set that to true. Oops. Okay. And the moment something is found to be not disintegrable, we set it to false, and it will never go back to true. Okay. That's fine. Alright, what's left? I want a map which tells me the highest settled piece of sand for a given XY pair. So define... This is going to be a default ticked, so everything defaults to 1. No, defaults to 0. That's why they've decided to start at 1. I don't know. From collections, import default ticked. Hi, so we want to highest Z, I guess, equals default ticked with a value of int. So it's going to be 0. It's going to be 0 for everything to begin with. And highest Z is going to map pauses. Pauses specifically where the Z coordinate is 0, I guess. Actually, it doesn't matter. We'll only extract the XY. Oh, no, it does matter. Yeah, so it needs to be where the Z is 0. Fine. Okay, so that we need to keep that up to date. Alright. Are we almost done? I said earlier we're going to build a graph. We no longer need that, I think. Because the moment a block settles, we need... Hang on. Yeah, we need a cube. We need one more map. We need to map every XYZ coordinate to the block that cube belongs to, because if we're falling, and we land on stuff, we don't know which block owns those things. So I suppose, yeah, we need cubes to blocks. I cannot finish puzzles on Christmas. My family would be mad. Well, I guess that's why Eric always makes only a part 1 for Christmas. Although a couple of times the part 1 wasn't exactly easy, but it was still just a part 1. Okay, so this problem is not exactly hard. I'm just trying to do it really nicely, so I'm trying to make all these methods. Okay, so cubes to blocks equals. So this is going to map pauses to blocks. Alright, so let's say block equals alright, we put the block in the list of blocks and we say for cube in block dot get cubes to no, this map needs to be defined up here. Cubes to blocks cube equals block. Alright, so if we land on a block, if we land on a cube, then we know who owns that cube, right? Like, another way of doing this would be, I don't know, I think this way is a good way of doing it. Alright, so alright. Are we almost ready to do the main loop? Okay, so for block in blocks, wait, sorted blocks, key equals get lowest point. No, that's not how you do this. How do you do this? Oh, just do it like this. Lambda b to b dot get lowest point. I know there's a way of doing this instead of writing that, isn't there? It's I forget now. Okay. So we go through the block, starting with the one that's lowest, right? We need to find it settle the location to settle. Or Okay, drop amount. Drop amount equals. So it's going to be... Hang on, let me think. Let's say drop to Z. So I'm saying I'm going to drop this block to this Z value. Drop to Z equals, it's going to be the maximum of the highest settled sand so far of alright, let's say highest Z maps a pair XY to the Z. I don't want to use a pos, I want to use a XY, so I'm going to highest Z. Hello, Amaro. Have you had a look at this problem? This one seems interesting for tackling with a game engine, because you can literally just let things drop. It's Tetris, basically. So I want to, it's going to be the highest Z for let's say okay, we'll map a pause, so it's going to be pause of cube dot x cube dot y 0 so highest Z, that should be a for cube in block dot get cubes. Okay, so what does that mean? For each cube on this block, we check what the maximum stabilized height or is already on the map. Alright. And then we drop to that height plus 1. So so the block is gonna end up, the lowest point of the block is gonna end up at this Z height. Now what? If we already know that we're gonna do that, then we might as well just do it now. So we need a translate method here, so define translate to height. For given Z. So the drop amount, 3D version of Tetris from 1989 that I played as a kid. Block out. 3D version of Tetris. I might have seen something like this. What console was it for? Drop amount equals. So it's gonna be my lowest point. It was written for DOS only, I see. It's gonna be self dot get lowest point minus Z. So cubes to blocks is going to have to be defined before this block. So we have to delete all its cubes. So for cube in self dot get cubes, remove, so delete I'm not sure about this cubes to blocks. It seems a bit messy. Okay, we'll just keep on with it, but there's probably a better way of handling that. So we delete its cube from the map. Okay. Now we change its endpoints to be the new location. So self.ends equals it's gonna be self.ends, the first one, minus pause 0, 0. We just call this DZ. DZ. Self.ends 1 minus. Okay, so that's where the new endpoints are. Sub. We need to define subtraction. Can we not? Or we don't. Or we could just get away with it and just do this. This would be negative. That makes more sense, because DZ is the change we want to see, so it should be negative. Correction, Sega Mega Drive Genesis also had a version. Oh, okay. And now, we re-add to the map. Equals this block. Okay, so now we okay, so we do block dot translate to height drop to Z. Can we just call this, I don't know, new Z? Okay, so now the block is sitting there. Okay, now we have to find all the blocks that we are now resting on. Now I'm sure in the input there's going to be some tricks. For example, if you have a long piece, and then another long piece lands on that long piece, exactly the same, like parallel with it, there's going to be multiple points at where it's landing on this, but it only counts as one block. I don't want to count it as multiple, because that matters, right? So that means we need to count the blocks we're resting on, not the number of cubes, which I might have accidentally done, but we didn't. Good. All right, so supporting blocks equals set. So every time we land on a block, we could just throw that block into there. Okay, so for cube in block dot cubes, space below equals cube plus pause 0, 0, minus 1. Right, that's the space below us. If space below in cubes to blocks Right. That means we've landed on a block. So cubes to blocks, space below. So we want to put that in supporting blocks. Right. The supporting, no, dot add that. Okay. Block dot get cubes. Alright, so once we've done this, supporting blocks will have a bunch of blocks that we are resting on, if any. The only time we do anything is if this set has exactly one block. That means removing that one block will cause our block to fall. So if length of supporting blocks is 1, what do we do now? We now say that block that we are resting on, supporting blocks, you have to do, okay, this is the hack list, supporting blocks 0, that just gets the thing from the set. That gets us the block dot is disintegrable equals false. So it used to be true, it's now false, and it will never become true again. Because we know removing that will cause this block to fall. So if we've done this correctly now, we need to count the number of different supporting blocks, not just the count of supporting grid cells. Yeah, that's correct. Because it's done at the block level, and you could have, for example, 2 blocks which are like this, and then you land on both of them, which would also be awkward. So, but yeah, you need to count the number of blocks. Alright. So now what? If we've done this, we should just run it and see if it crashes. Yep, unhashable type block. Oh, because it's not a data set. Did I not make it a data set? Do I want it to be a data set, data class? It is a data class. Oh, but it's not frozen. We can write a hash method. Or we can just make it... Okay. Ends, just make this a list. List. Pause. Okay. Everything should still work. And then we want frozen equals true. Oops. Yeah. And when we modify endpoints, self.ends. Alright, here we're not allowed to do this. We have to say new ends equals that. Those are the new endpoints. And then just do self.ends.clear and or e in. Okay, it's a bit hacky, whatever. Self.ends.append. I'm only doing this so that it'll use a built-in hash method, because I can't be bothered to write my own. Self.append e. Oh no. Oh yeah, no, that's fine. Yeah. Wait, we're not allowed to change this disintegrable, are we? If it's frozen. Let's see. Unhashable type list. What? Space below. Cubes to block. Cubes to blocks. Space below. Space below is a... Cubes to blocks. The key values should only be pauses. Why? Cubes to... So what is it saying? It's saying... Cubes to blocks, space... So... Which bit doesn't it like? It doesn't like this, or it doesn't like this? Both involve hashes. Space below equals cube plus pause. Okay, so that gives a pause. So that should be fine. It thinks this is a list. Cubes to blocks. We only ever put blocks in it. I'm confused. All right, we've got to print stuff here. What does this look like? Come on. So that's a block. Oh. I see. I'm making some assumptions about how this works. So we can't hash this because that's a... Okay. I thought hash would just... Alright, tell you what, go back to the tuple. That actually makes more sense. Alright, define hash. I just want hash to be the memory location. Alright, let's just what's wrong with this? Yeah, change this back. Wait, go back, go back. Okay. Unhashable. Okay. Block. Just let's go back to this. Find hash return hash of self dot Can we not just hash the memory location? I just want this to be unique. I don't know how to do this. Let me Google this. ID? So it's gonna be what? Self.id? Is that a thing? No, it's not. ID? Ah. Yeah, just do that then. Is that... See, I'm working with stuff I'm not familiar with, so I don't know if... Let me see the blocks. Well, what do they look like now? Is it disintegrable? True, 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 true. Are there any falses? False. Okay, it's doing something. Hot one. Print sum of b dot is integrable. I need to copy this because I'm not going to be able to spell it again. Is disintegrable. Will be in blocks. It's just that, right? 1354. All right. I think the logic was correct, but I'm working with some things that I'm not familiar with, especially at, like data classes and stuff. So there could be something completely wrong here. One, 3, 5, 4. No, it's too high. All right. This is kind of messy. All right, we'll try the example then. Did I? Okay. Let's get this example. Six, and the correct answer should be 5. Right. How many bricks are there? 7. So we've said 6 and it's actually 5. So let's have a look at the Oh! Hang on. The problem with this is you don't get lowest point. Is this is being modified because we're changing the lowest points. That's a bit weird. Let's make a copy then. No, it makes a copy, doesn't it? So this should make a copy. So even though we're changing the lowest points, this shouldn't change the order just because we're dropping things. Otherwise, it would just keep going to the bottom block. So yeah, that should be fine. Did I ever put anything in highest Z? No, I didn't. Oops. That was the last thing to do. Okay, highest Z. So what are we doing? I think we're dropping everything onto the ground. Why? Okay, whatever. Highest Z. So we want. Yeah, we never populated this. We literally just. Okay. When do we populate it? When we drop the block. Okay, we've now dropped the block for cube in block dot get cubes highest Z for cube dot x cube dot y 0 equals the max of whatever it was before. Well, no, it is equal to this position here. It's going to be cube.z. There can't be anything above us, so yeah. All right, does it work now? Still gets 6. Or at least we're using highest Z. Supporting blocks. Okay. What now? At the blocks, let's see what they look like then. One, 0. It's because they. Okay, we're gonna have to match these up with the example. Right, so. So this is 0, 1, 2. So it's yes, it's got 3 points in the y direction. So which block is this from the diagram? So it's, hang on, it's got Z value 1 So this must be A from the example they've got, which is at the bottom. So say z value 1, x, y value 0, 1, 2, x value 1. Correct. Alright, so that's where A ends up. That's correct. Is disintegrable? False. Is that correct? Correct. Because B and C are resting on it. Alright. What next? B. What? No, let's just look at our blocks. Right, so the next block. Block. 0. So z equals 2. Y is 0. And it goes 0, x equals 0, 1, 2. Okay. So what does this look like? So z equals 2. Y equals 0. X equals 0, 1, 2. That is B. Yes. B. So we've said it is disintegrable, and that's correct. It is indeed disintegrable. Wait, so if it's 6, okay, we've said all the rest can be disintegrated. So the one we've got wrong is we've said brick F can be disintegrated, but the correct answer is no, it can't. Alright, so what happened here? F. Oh. I know what's happened. This get cubes. Alright. Space below. If our block is vertical, then the spaces below are actually ourself. So we should not put our own block, in cubes in supporting blocks. We can't support ourselves. So if cubes is not equal to our block. So what's happened is it's going through the blocks of this vertical thing. The bottom block is resting on something. Okay, so that becomes a supporting block. Then the next cube actually belongs to ourselves because it's part of our chain. So a different way would be to just take the bottom cubes, but whatever, it doesn't matter. Let's do that. 5. Okay, that's the correct answer. For the example. Alright, try running it on the big one. $522. That is like half of what it was before. Correct. Part 2. Please give me a nice part 2. Just nice and easy. I've already put so much work into making my code really efficient and clean, so let's see. Alright, disintegrating bricks one at a time isn't going to be fast enough. While it might sound dangerous, what you really need is a chain reaction. Hello, Smab UK. Thanks for the star. Part 2 is also nice? Okay. You'll need to figure out the best brick to disintegrate for each brick to determine how many other bricks would fall if that brick were disintegrated. Okay. Oh, I see. So we need to wrap up this whole drop process we've done as a kind of like a fall method. So we take a brick, we tell it to fall, and then it falls. Right. So we could just do the slow way and just go through all of our bricks from bottom to top every time, see if one of them falls, and if it does, make it fall, and keep doing this until nothing falls. Or we could yeah, but then we'd have to reset the boards every what is the sum of the number of other bricks that would fall? For the... Oh, for each... Okay, yeah, for each brick, we want to find out how many would fall. And we're just adding them up for all bricks. Okay, fine. So the disintegrable ones, we can just remove. We know it's 0 for them, but I mean, it doesn't matter. Okay, so... Alright, I don't want to simulate them falling, because then we have to reset the positions of the bricks every time. What, can we just work this out? So... using like a queue or something. So, okay, so given a brick, we already have a boolean saying whether it's disintegrable or not. If it is disintegrable, that means removing it will not cause any other bricks to fall. Alright. If it isn't, then... Well, what's the cleanest way to do this, given what we have? We could... just look at the spaces above us and say... So for each brick, we're trying to work out how many would fall. Which would make most of the logic we've already written we can just discard if we make this method, because this method will actually tell us whether something's disintegrable or not. So that is good, I guess. Okay, so if... Alright, so we take a brick. We want to see how many would fall. So we want to look at all the bricks which are resting on it. We can get that. We just look at the spaces above. Alright. Then what? We want to see how many bricks those bricks are resting on. And if they are resting on only my brick, then we know they fall. Then do we not just repeat this recursively? It's really just like a depth first search thing through those bricks. Is there anything I'm missing here? Doesn't matter where they fall to. So we don't need to actually do the fall. We just... Because if they fall, then... Then no matter where they fall to, whatever is resting on them and not resting on anything else will also fall. So... So this is, we can make a recursive method. Find out how many other bricks would... So if we want to find, if we have this function f, say, which gets the number of bricks that would fall, for each brick that's resting on us, we apply that f function to each of them, and then add them up. That's what we do, right? And then recursively return that number. Alright, let me try and put this together then. So I'm saying, up to, so we're defining method, that's pretty much what I did. Yeah, I guess that is I mean, it's a fast way to code it, because then we're just relying on recursion. It's not over 1,000 bricks, is it? Even if it is, we can be a bit naughty and increase the recursion limit to 2,000. Okay. Alright, define get num all. Not the best of names for... Not the best of descriptors. For a given block. Should we do like hashing? So we say table equals that. If block in table return what we have stored. Okay. If block dot is disintegrable, then we don't need to really do anything. This, oh, we can leave this step out, to be honest. No, we don't need to do that. Okay, just say so, okay, there's two steps here. First, we find out all the blocks that are resting on us. And for each of those blocks, we find out how many blocks they're resting on. If it's just one, then we add the getNumFall number for that block. Otherwise, we add 0. We don't add anything. Is that right? Probably. Okay. So we have to go back to... Okay, I don't like... Okay, whatever. I think this cubes method is a bit... If I had just gone with what I said a long time ago, which was create an undirected graph, or a directed graph, mapping blocks to what they're resting on, but... Alright, we've done this cube approach, let's stick with it and just finish off. Alright, so... supported blocks, so how many blocks we are supporting, equals... Sorry, there's some karaoke going on outside my window. Is that coming through on the mic? Doesn't seem to be. Okay, good. Where am I? Okay, so supported blocks equals, just do what we did before. I don't like this individual cube approach now because it's just a bit more work than necessary, but we can just repeat it. So we basically do this sort of, but the other way around. Alright. The cube in block.getCubes, space above. But we would, okay, so it's going to be that if space above is in our cubes to blocks map, there is a block. Now that block might be ourself because of the way I've written this, so if it's not ourself, then supported blocks dot add cubes to blocks space above. Not the cleanest of loops. Alright, so now we've got a set of supported blocks that are resting on us, okay? So, for B in supported blocks, see, well, this could have been wrapped up as a method, but copy paste, whatever. You want to copy this whole thing again. Supporting blocks equals set for cube in b.getCubes, space below equals cube plus that. Space below in cubes of blocks not equal to b. Supporting blocks dot add cubes to block space below. Alright, then what? If length of supporting. See, my original idea of making a graph would have been perfect now. It's neighbors. Number of neighbors equals 1. That's all you would need to do once you've done all the neighbors. I might rewrite it like that before uploading to Gist. Okay, length is supporting blocks equals 1. That means we fall, right? So okay, result equals 0. Result plus equal get num fall b. So only if that falls, then we add get num fall for that block. Cache the result. So now part 2 would be sum of get num full block for block in blocks. Should we try and write this differently? Let's say map get num for blocks. That's nice. Print total 2. Will it work? 0. Alright, so are we just ending up with an empty supported blocks here? Space above... is not equal to B. So B is this block that's the block that's on us. So we're checking all the spaces below. And if there's... Wait. We don't need to do all this, do we? We already know. We already know. If is disintegrable. We've got that boolean. Just use that. Okay, if... B dot is... If... Not... B dot is indisputable. That means it will fall. So this is all redundant. So if it will fall, then we add result plus get num4, but we're not adding. It's going to be +1, isn't it? Because we're not including it, the block itself. Is that why I'm not getting anything? Okay. 47637? Too low. For each brick, determine how many other bricks would fall if that brick disintegrated. What is the sum of the number of other bricks that would fall? Alright, let's go to the example again. Two? Sounds low. What should it be? 7. Disintegrating brick A would cause all 6 other bricks to fall. Wait! Oh. Oh. Oh, I see. My logic is wrong. Because... okay. If all those things were to fall... How do I explain this? Yeah, so if... So here, we're not taking into account that it's not truly recursive because this music is distracting me. The karaoke going on outside my window, so I'm gonna have to. I need to try and finish this soon. Okay, so when you remove A, both B and C, which are sitting on it, get removed. And then, okay, so disintegrable is not the right thing we're looking for. Yeah, so, okay, if there might be a situation where if you remove a block, nothing falls, okay? But in this scenario, if we are removing a block below, it might remove all the other supports. In which case, we do need to include those. Okay, so how do I actually do this? I don't think recursion is the right approach here then. Or at least not the way I've done it. Maybe we just want to do it just like iteratively. So we just say, we just simulate mark blocks. When we see that blocks are going to fall, we mark them as falling. And then as we look up the blocks, we can figure out... that would be like quadratic, won't it? But it's not a big deal. Should we just do the slope? Yeah, let's just do that. All right, so what I'm trying to say is we just do a... Okay, if we want to find the number that will fall for a given block, we just mark that block as falling. And now we just go scan through all the blocks from bottom to top. And check what their supports are. And we ignore any supports which are marked as falling. And if it has no supports, then it is also falling. As long as we go from bottom to top, this should just work. It's going to scan through all the blocks every time. So this is quadratic in the number of blocks. I'm pretty sure you can make some sort of recursive method out of this, but screw it, I don't care. All right, so how do we do this? Start again. All right. So we want falling is falling equals a set. All right. So every time we see that a block is falling, we put it in the is falling. So block, so is falling dot add block. It's not technically falling, but it's disintegrating, but it's whatever. It's like it's falling. Okay, now for be in, so go through the entire list of blocks from bottom to top. So sorted blocks key equals lambda b to b dot get lowest point. So we go from bottom to top. We do this thing again. Just compute all its supporting points, just like that. So if the space below belongs to a block and it's not B, and if it's not falling, we add it to supporting blocks. And the moment that happens, we know that this one is not falling because it has supports. So we can actually just we don't need to calculate the supporting blocks. The moment we see a support, we know it's stable. So we say break. So if we didn't break, then we're going to hit this else. So that means we didn't find any supports. So is falling dot add B. Yeah. Then return length of is falling -1 because we don't want to include the current block. Is that it? Try now. 42. Well, that's way over. Get num for... Hang on. So for B in sorted blocks, from bottom to top, even the ones that are below us, doesn't matter. Oh! Because we're including all the ones that are on the ground level as well. So, hang on, so... if space below dot z is less than or equal to 0, we're on the ground, so it's fine. Continue. No? Okay, that wasn't the issue. Wait, no. We don't want to continue. We want to say... break. Not break, not continue. Break is the opposite. We want to break. That means we're fine. So there we go, 7. That's the correct number? Yes. Alright, come on. Please. I've already coded... What was it? I spent 3 hours on problem 21 without finishing, and now another 2 hours on this, so that's enough, please. So now we're doing quadratic, so it's going to be in the millions of operations. Yeah, I'm sure you could do some smart recursion or something. There we go. Phew. Okay. Just trying to think about what would be. Thanks for the stars, MapUK. What would be the efficient way of doing that? I guess something along the lines of recursion, what I was doing before, but you just have to account for the fact that your supports may no longer be supports, so it's like... So... No, I don't think you can do it recursively the way I was doing before. Yeah, I don't think you can make it work, because you could never know until you've iterated at least a bit whether supports will exist or not, so... Maybe some sort of graph approach. So, Smab UK, yours runs quickly. What were you doing? Something similar to what I was doing then? And is it actually quadratic or more efficient? I think it. So if I did this using graphs instead of these stupid get cubes, so we've got graphs of every block is pointing to the blocks which are touching it above and below. That would make a lot of this, well, first of all, it would make a lot of this cleaner. Second of all, if we knew that, then... hang on. Okay. I can have a look at yours. Look at the connections above and below. So do you put them in a graph? Supported by supporting. Okay, that's nice. Yeah, it seems like a useful thing to have. And then... disintegrated or fallen. For each... count fallers above is a recursive method. Okay. What's this? Oh, is this just for part 1? Alright, so the key is this method here. For each count. Okay, so count fallers above, which is my method. Hello, Elon's musky crack. It looks like you were topless in the thumbnail. So is that why you joined? Sorry to disappoint. Naked advent of code would have been wild. Starting bricks for part 2 are the inverse of the... Had to double check. Was it actually? I guess if I'm sitting at like this kind of angle, then maybe a bit. Starting bricks for part 2 are the inverse of the counter bricks in part 1. So for each This is basically what I was doing, wasn't it? Is it? What was... Oh, because you're processing them... In which... what order? Yeah, let me look at this. We count above... Disintegrated or fallen. So that's never resetting. That's accumulating stuff. Okay, fine. Bottom to top. So was that basically the key? If I had gone bottom to top, it would have been fine. But I just went in an arbitrary order, didn't I? And I didn't actually need caching or anything like that, because it's... Well... You can... Because there's no cycles, so it's... I'm adding any that have fallen into a list, excluding them from supports. Yeah, that makes sense. Bottom to top is the key. And yeah, you have to add that exception as well. So kind of, yeah, similar to what I ended up doing, but then I just went through the, yeah, that makes sense. Okay, so I was not far off, but... Okay, that's enough coding for today. Okay. Let's have a look at the stats then. Excuse me. Oh, that's interesting. 21. Oh no, that's a lower proportion. It's half, well, and this is 2/3. Okay, so that doesn't necessarily mean 21 was easier. Actually, I guess it was harder, because 21 was hard, and I've not finished it. So tomorrow I'll try and work on that. I have an idea for how to do the algebra properly, because I was making a complete mess of it in Microsoft Paint, and pretty sure some values were wrong. So yeah, 21 I'll work on tomorrow, but that's good that we got 22 out of the way, so I'm not that far behind, because yesterday I had to fly on a plane. I was tempted to do some Advent of Code on the plane. I have done Advent of Code on a ferry before, but never a plane. Not had much time lately, so I've only done the easy ones recently. I wanted to try and do the coding game competition as well, because that's started now, but I think I'm going to leave that until... It runs for 3 weeks. Coding game. I've been doing coding game pretty regularly now, like every year since quite a few years now. Oh, they've changed the... It all looks different now. Oh, I don't want to onboard, I just want to see the competition. Alright, whatever. Yeah, well that's after Christmas. I'll be free to do that. I'm not gonna get any holiday, am I? That's my Decembers these days. That's how things go. Most of December is taken up by Advent of Code, and then the remainder, including New Year's, is going to be taken up by coding game. I don't mind. I think that's actually a fun way to spend Christmas and New Year's. Okay, so it seems on my leaderboard, 2 people have done that. Umaro is catching up as well, so I need to work on 21. Oh, let's check out Captain Coda as well. Captain Coda is all caught up as well. Cool. Ooh, look, quite a few people have left 21 unfinished. I guess that would mean it's quite hard. I think tomorrow I can do it. I think I have an idea now, but I only did today's as I couldn't sleep and got up at 6 a.m. Yeah. Oh, and what was the other thing I wanted to check? I want to see... Oh, no, I'm not going to look at 21 yet because I haven't finished that. We'll look at 22. 12 minutes 50? Yeah, sure. I think I spent a lot of time making all my classes, like my blocks class and everything nice and neat, but I mean, you can do some pretty dirty for loops, just have everything drop and drop one by one or whatever, and it'll work fine. So I think ooh, so it took 10 minutes to do part 1 and then just a couple more minutes. Oh wait, so 11 minutes 33 to do part 1, and then it took him another minute 20 to do part 2. I guess... I suppose. That's pretty impressive, doing part 2 that quickly. If it took you that long to set up part 1, I suppose. Yeah, okay. Half an hour, 21 minutes. Okay. Cool. Shall I take a quick look at Twitch? See if anyone is doing Advent code. Oh, and then I'll go raid Alka again because he's got a visualization here. This looks nice. Oh. No, he's not actually doing Advent of Code. You can't see this on stream because I'm using my regular browser for this. No, he's not doing Advent of Code. Alright, we'll just leave it. Alright, yep, thanks for watching. And tomorrow I'll try and finish off both problems or just get more progress on 21. So, see you tomorrow. Bye-bye.